Thank you for the introduction. I will now share my screen and start with the presentation. So this is the presentation. It is called Dealing with Real Datasets, How to Treat Data Assets to Create Business Value. And it is part of the topic Automation and Data Ops. Overall, I'll give an introduction about me, so who I am and the daily job that I do. And then I will introduce the problem that I want to treat in this presentation. And then there is the core of the presentation, that is 3 business problems. So basically problems that product owners may ask developers to solve, and the solutions that the developer should actually be able to implement in order to solve efficiently these problems. And then there are the final considerations. So given the entire talk, what suggestions can be given to companies and to developers that want to enter as data engineers. All right, let's start with the introduction. So my name is Pietro Guardati. I studied robotics as a Master of Science, and then I started my career as a machine vision engineer. So I basically started building algorithms based on data. These algorithms were used to solve computer vision problems. Then I switched to data engineer after a few years, and I'm specializing into this field. And in fact, I'm working for Kpler currently. And speaking about Kpler, Kpler is a leading data provider in the commodity markets, meaning that we aggregate. We actually do 2 activities. The first one is to aggregate several sources of data. We aggregate videos, images, and then textual information, indeed about the trading of oil and of gas, and we're going to go also in other markets. So the first service that we provide is that we aggregate the data, and we sell this sorted, clean catalog to companies and organizations that want to do analysis. On the other hand, we also perform the analysis by ourselves, since we are the first that get in contact with this clean data, and we sell the reports. So it's this dual activity, and it's a full data engineer-centric service. Let's go next. All right, the introduction is finished. Let's go into the problem. The problem that I want to talk about is the following. Imagine that you have a product, so a car, and this car has a camera on it and is recording data. What a company would like to do is to use this data from product 1, the car, to develop another product. For instance, they want to develop a car detector in order to avoid the collisions with the cars in the front. So this is the problem, and I want to give a note about the entire presentation before to dive into the topic. This presentation is going to be about tools, and it is a bit high level and addressed in particular to organizations, since like organizations that have data assets, so they already have the data ready to be used, and they want to extract business value. And on the other hand, it is meant for young graduates that have academic education. They probably are good at maths, and they want to have few insights into the data industry. So they are great at academia, but they don't really know what the job could look like. All right, so let's dive into the problem. I will start with a few business problems, so product owner asking for solutions and the solutions that the developer is meant to know. The scenario in particular is the following: product owner, the owner of the product car, and the product owner as well of the car detector, the new product that they want to build. And we have also a junior developer that is assigned to the development of the car detector, to the car detector project. So the first question that the product owner could ask is, please, could you develop the algorithm to avoid the collision? So first to detect the car. Here there is a reminder. So the scenario have a young graduate, is great at algorithms, great at math, pretty good at machine learning. So the task that the product owner just cast to him is perfect. Algorithm totally doable for him. He has basic coding skills, but for this task, that's not going to be a problem for him. Or at least, if the task is basic, if the task is basic, that should be fine. So we have a production environment, the company is a production environment, and the product owner tells the developer, all right, you can find the images of the cars inside a bucket, for instance, an S3 bucket. And the annotations, the human annotations of where these cars are inside a sequential database, a Postgres, for instance. Notice here, it is seriously not granted that the annotations are available, but let's say that in this case, they are. So the developer can just extract this data manually, let's say for now manually. So she can use the interface, for instance, pgadmin to extract the data from Postgres, and another high-level interface to extract data manually from S3. And then he can get the data inside the development environment. So once he extract, he build the training algorithm, and voila, he has the model. It seems kind of straightforward, but indeed a supervised algorithm, that's what it is after all. It's almost straightforward nowadays, or at least a first iteration of it. Then the product owner, let's say that he's satisfied about the results. So he asks the developer, all right, now put the model, the algorithm that you developed, into production. However, here the point is that the developer is a young graduate, so he does not know what he does not know what the deployment is, and he does not know what the production environment is as well. So the product owner tries to clarify the situation and tells him, all right, you have to first of all build an API, so a software part that allows users to access the algorithm that you just built. Then you have to create a Docker image to reproduce the environment where you actually built your algorithm. And once you have the environment and you have the mechanism to access the algorithm, we can actually replicate what we developed and put this into the production system to install it there and allow the user to interact with it. Despite the concept is clear now, let's say you need something to access and something to replicate the algorithm inside another machine. At the development level, the young graduate does not know how to implement neither the API, neither the Docker. So somehow he needs to learn it, or at least what is expectable to happen is that he's going to spend days on Stack Overflow. And after days on Stack Overflow, hopefully he's going to arrive to a configuration like this. So he is expected to develop a Docker image and put manually the Docker inside the production system. However, now there is the third question, that is, new data just came into our system. Can you retrain and redeploy? So redo the operation 1 and redo the operation number 2. And here there is the reminder again. The developer is a young graduate. So he is great at algorithm, but he has basic coding skills. And due to the deadlines, he didn't take care of the reproducibility of the code, neither of the maintainability of the code. So his training script was quite dirty. There were local paths committed into it, just meant for a one-shot execution. The code was unformatted, not production ready. And other several software principles were violated during the development, or at least production, like principles that were meant to code that should be shipped into production. So when he has to face the retraining and redeployment of the actual of the model, there are a couple of issues. First of all, there are many operations involved, meaning that the training has to happen again, the extraction has to happen again manually, everything has to go correctly nominally, and then the deployment as well has to be performed manually. But supposing that everything goes, let's say, smoothly, at least in this part, there could be inconsistency in the service. And with inconsistency, I mean, let's imagine that new data arrives, and then a new model is created, and then the new model is deployed. Then let's say the new model is indeed deployed into production. And after a few days, a customer arrives and tells the product owner, hey, the Toyota cars are not detected anymore. Why? However, nobody actually checked on the quality of the service, in the sense that yes, the algorithm said that the cars were detected, but who checked that the actual Toyota model, the test case Toyota model was fine? There weren't automated tests there. So let's say these steps can be actually automated, and that's the way they should be done in order to avoid these issues later on. First of all, the extraction should be automated, and there are libraries. Here I say Python libraries because are the ones that I'm used to, but there are many out there. So let's say if you use Python, there is, for instance, the Boto3 library that can help automating the extraction of S3 data. And for the Postgres, there is the PsychoPG2 library that can automate the queries to the sequential database. If you have a NoSQL database, it's not gonna change much. It's just a different library. So, all right. Once the extraction is automated, also the training can be automated. And in particular, the entire pipeline of extraction training can be automated. And the way that the industry is standardizing this, at least with the default tool in the open source community, is Airflow. Airflow indeed allows the user to build workflows, meaning that the users can specify, all right, first extract the data, wait for the execution, and then perform the training of those data, or maybe those data plus the old ones, etc., etc. And in this way, we can automate the entire pipeline of training, extraction, and then training. Lastly, the deployment. So the model is ready. The pipeline has finished nominally. It's great. Then there is the let's say deployment part. So what can we do better than before? We can automate it, and the automation consists in two steps. The first one is the continuous integration part. So we should ensure that tests are performed at a code quality level, but in this case, in this particular case of the data model, of the machine learning model, let's say, not the data model, we should perform automatically a test case for product scenario, like image of Toyota car, is the car detected? And in this case, we could avoid the issue with the customer that complains about the new model that actually does not detect the car. So it's like a model version 2 that is performing less than version 1. This should definitely be avoided. And then there is the CD part, that is the continuous delivery or deployment. That can be done with several tools. Here I mentioned the GitHub Actions, but in general it's something that allows to get the the tested code and put it inside the actual production machine. Overall, what I want, let's say, to state is that the retrain and the redeploy should actually take one button. With one button, one pipeline should be triggered and create the new version of the model. And if something goes wrong, then development should be done until all the checks are actually passed. And here comes to the final. I come to the final considerations. First of all, for companies. Companies, let's say, that have clean data, so the data are already there. They don't need to be aggregated. They are kind of clean, but there is a complex model. Imagine you want to develop a complete autopilot, and you already have all the recordings and all the annotations are there. Then it's probably, I mean, this is a very complex problem, but the problem is also algorithmic. So you need someone that really understands the details of algorithms, and that's the data scientist is probably the professional you're looking for. However, if you have messy data and let's say, or even you do not have data and you want to build catalogs, sort the data, do business intelligence and creating a warehouse where at a company level people can access and get their value, or analysts can actually perform their analysis, then that's the problem is probably a software problem, and the professional that is probably should be hired is the data engineer, since he should possess those principles of software engineering that are meant to build these tools. Let's move forward. All right, that's company-wise. Let's move to the young graduates part. So if you are a student or a graduate, postgraduate, whatever, you get the point, and you want to start the career as a data engineer, first thing that I suggest to learn is the versioning tool. So learn Git, because if you know well Git, your stress level as a professional will decrease substantially, because let's say every day you will use this tool, and if you use it well, your workload is going to be organized in a totally different manner. I don't want to go in the details of this, but believe me, put a bit of effort, at least acknowledge the importance of this tool. Then there are, let's say, two suggestions that, well, if you check the LinkedIn, for instance, the job posts of LinkedIn, they are everywhere, those two requirements. This one, the software, so get to know one programming language to build the software. Here I reported Python and Java. Python because, well, there are many libraries in general for data, and I reported Java because it's let's say many framework for big data are written in Java currently. So let's say pick one of those two, the one you prefer. Probably Python is slightly easier, but it's up to you. And lastly, data. So SQL should be known, at least if you work with data, because all the database speaks SQL. And in general, even if you write Python code, if it's about data, knowing SQL allows to build more robust pipelines. A last note. So I mentioned Git, I mentioned API, I mentioned Docker. And I already mentioned that these are mandatory skills for software developers. If you're not familiar with this, I suggest to check the full stack nano degree at Udacity, since I did let's say I learned Git brute force API. I learned brute force as well and Docker as well. And then I did the course. And even after, let's say, creating those, or at least using these tools, brute force, I found the course as a great resource in order to sharpen those tools. All right, so that should be everything from my side. I hope it is enough, but if it's not, I leave my contact here, my name, surname. I have LinkedIn, I have GitHub, and here I report also my working email. And now should be a question and